Hello everyone, my name is Dina Ata. I'm working as a petroleum engineer at Khalda Petroleum Company. I want to welcome all of you today, and I want to welcome engineer Ahmed Elzeftawy, who will be our presenter today. Let me introduce him to you. Engineer Ahmed Elzeftawy had 34 years of experience in oil industry covering the Middle East, coil tubing, nitrogen services, training, supervision, operation, and maintenance, wireline testing, completion, and downhole tools, operation and training. Engineer Ahmed got his bachelor's degree in mechanical engineering from Cairo University in 1983. Engineer Ahmed has work experience in coil tubing, completion, wireline, and well intervention, covering the following as operator, supervisor, consultant, instructor, and a manager in more than 70 different countries. We will have an amazing session today. I wish all of you to enjoy it. So, Engineer Ahmed, now the floor is yours.
Thanks, Dina, for the quick introduction. Let me start. Hello, everybody. Thanks, Dina, for the introduction. And today we are here together for the course of well intervention. I will be with you for an hour, hour and a half, depends on the progress we are making. First of all, let us understand what well intervention course means. This course is a mandatory for everyone who goes to the field and in charge of a job. He has to go through this course, and it's a mandatory that this course has to be repeated every 2 years. The course normally is about 30 hours, but we are going to make it in 4 sessions. Each session is one and a half hour. So it will be a simplified course of well intervention. If you look at the dictionary for the meaning of intervention course, intervention means act fast. And this is the aim of the course, because the well intervention is an art dealing with live wells. Live wells, which means it's a produced well. It has pressure. Pressure is the key word. Pressure is the monster that we need to know how to deal with. So there are 2 organizations actually worldwide issue this certificate. One based in the United States of America, which is the International Association of Drilling Contractors. The other one is based in England, which is IWCF, stands for International Well Control Forum. But as I said, this is not a course of IWCF or IEDC, as this will be through the university, and I believe you will get a certificate at the end of the course. We split this course into 4 sessions. The first session will be today, which is today. It will be about well control. We'll have another session of completion. A 3rd session will be a wireline. The 4th session will be coil tubing. First of all, I need to share a secret with you. In all my years of experience, which is from 95, teaching in almost 18 to 20 countries around the globe, I always talk to people. This is the first time to talk to the wall. I used to talk to the wall when I fight with my wife, but this lasts for a few seconds. But talking for 1 hour to the wall, I mean to the computer, yani, this is a unique experience for me. Hope I can manage. Yani. This course, actually, the topics we will talk about is well control, risk assessment. We will talk quickly about what's pressure and what's volume. And we'll have a separate course, as I said, for completion, another one for coil tubing, and another one for wireline. Today, we will discuss only well control. Let's start from the beginning. And to do any job, even I'm not talking about oil field. If you have a problem in your car, to fix your car correctly, you have to go to a good mechanic. Then this mechanic has to have the right tools to fix your car, and he has to have a plan how to fix it. The same thing if you have some plumbing work at your villa, good plumber, good equipment, he has to have a plans and procedures. The same thing applied to the oil field industry. And we said that the 3 factors govern the success of any well control. 3 things: human, equipment, plans and procedures. And from here, we have to fight. I like fighting a lot, and this is one of the problems I'm facing now, that I cannot fight with you because I punch you, you cannot respond. Many people say, Ahmed, what you are writing is wrong. This could be right 50 years ago. But right now, equipment should come number 1. Human do mistakes. Human doesn't obey orders. But equipment, they don't do mistakes. Everything is computerized now. So you should write equipment number 1 and then put human number 2. And I said, well, who invented equipment? It's you and me. Always human comes number 1. And I gave example, I said, if a good operator can run junk equipment, but not vice versa. If you have a brand new equipment and have stupid operator, he will not be able to run it. And if he run it, he will destroy it. So human comes number 1 before equipment. And that's why when we hire a gentleman or a lady to join the oil field industry, we have to check that he is the right person. So we have to go through a sequence of questions at the end to be sure that we select the right person. First thing is fitness. The person has to be fit for the job. When we say fitness, I mean physically and mentally. In my experience, I faced these problems many times. I met with people who might be 40 years in age, but his brain is a kid. We don't like to send kids to the oil field. We need to send growing people. That's why when we interview a gentleman, it's a science. Some of the question I start asking him question is I lower my voice to the maximum to check if he's listening or not. Sometimes we ask questions that makes you nervous to see what's your behavior when you are nervous. Some people, when he get nervous, he will grab the chair sitting on and hit me on my head. This will be his behavior exactly when he goes to the oil field and have a problem with his friend. So we have to check that the people are physically fit. I hired a gentleman a long time ago when I was an operation manager in Oman, working for Shell. We hired a gentleman, and one day in the field, he feels sick. So he went to the medical center, and when the medic checked him, he discovered a metal object underneath his skin. This was what we call a pacemaker, to adjust his heartbeat. And Shell raised the hell, because how you hire a gentleman who has a heart problem to work in the oil field? It will be a fatality one day. So we have to check that he is physically and mentally. ASK stands for attitude, skills, and knowledge. We need people with a good attitude. Attitude is a science, actually. It's an art, how to deal with others, how to deal with your friends, colleagues, your wife, your father, your friends, your supervisors, your workers. And many people believe that this represents 100% of what we need. And if you look at this page, if we consider the alphabetic A, B, C, D, and we put A as 1, B as 2, C as 3, and let's go for the word attitude. A is 1. Then T, if you look at T, it's 22. And then you go through that, you'll find that attitude is 100%. It might be a coincidence. Yes, it's a coincidence. But it reflects the fact that attitude is very, very important. One day I was working as an operation manager and I hired a supervisor. He was excellent in English. He is an engineer and he worked 12 years. He has 12 years experience. And he was working 1 month off, 1 month on. After the 1 month, I asked him to come to my office. And I said, thank you, don't come back. What was the problem? He used, when they are in the field, to go to the mess to have breakfast. If he found his helper is sitting in his preferable chair, he goes to the helper and asks him to move, take his breakfast and eat somewhere else because this is the chair he liked to sit. I fired him because of that. This is a very bad attitude. He will destroy my team. So I said, thank you, don't come back. Attitude is very important. Skills. We need people with the skills. Skills is very important as well. And I always say people, I have 2 types of people. Rock type and sponge type. The sponge type people, if you put the sponge in a bucket of water, the sponge will absorb the water quickly. Go to the rock, put it in the bucket of water. Come after a week, it is a rock. It will change, yes, but this will take a year. We need sponge type people. We need people that we send to the field, they gain experience from there quickly. When they go to the courses, they absorb information quickly. This is very important. We need people that has knowledge. There is a big difference, by the way, between knowledge and experience. Some people say, this is the same. I said, no, it's not. In the past, my supervisor said, Ahmed, you need experience, you need knowledge? Go to the field, you gain knowledge. I went to the field, I gained knowledge. But the question that remains, did the knowledge I received from the field is correct or wrong? Believe me, many knowledge I gained from the people that has experience in the field was totally wrong knowledge. The knowledge I got in the field that if I connect 2 hydraulic hoses with a quick coupler, quick connections, and if these quick connections are dirty from desert, it has grease and sand, people in the field told me, no problem, bring a bucket of diesel with a paintbrush, clean these connections, then it is shiny, connect them together, job is done. And I used to do that, perfect. But when I gain knowledge from reputable places, I discovered that what I was doing is a totally disaster. Because when I clean, I use diesel to clean these quick connections. When I connect the male and female, what makes the seal? It is the O-ring inside. Diesel is enemy to the rubber. Enemy to the rubber, yes. It makes the rubber dry, so it doesn't seal. This is the first mistake I was doing. The second mistake I was doing is when I clean with diesel and connect these together, traces of diesel will go to the hydraulic circuit, will go to the oil, the hydraulic oil in the circuit. Time after time, what's running in my body is not blood, it's mixed grill. the hydraulic circuit, what's running is not oil. It's hydraulic oil mixed with water by default and with diesel. So the performance of the unit will not be as it is designed for, because the media you are using is very important. And you have to understand and to believe that the hydraulic oil I'm using in Egypt, where I live in now, in that unit, and if I decided tomorrow that we need to send this unit to work in Aberdeen, in England, I have to change the hydraulic oil, because the hydraulic oil I'm using in Cairo, one of its character temperature, for example, it is to -5 to +50. But when we go to Aberdeen, the hydraulic oil we should use there, it is from -50 to +5. So it's totally different hydraulic oil. many knowledge I got from the field was totally wrong. So knowledge, you have to get it from reputable places. So there is a big difference between knowledge and experience. And by the way, this course, we are teaching this course as per the API standards. And every knowledge that comes out of my mouth, I try not to exceed the API. And if I'm telling you some information which is not API, I will tell you this is my experience, or this is my beliefs, or this is my, but our frame of work here is API, American Petroleum Institute. It's like FIFA in football. The API, the American Petroleum Institute, they put rules for us so we can deal together. We can understand each other. Also, we are many nationalities, came from everywhere in the world, but we follow the same rule. So knowledge is very important. Team effort. We're still selecting the people that we use to work in the oil field industry. People that work in a team. Mo Salah, Cristiano Ronaldo, Messi, best player in the world. Okay, let's have Messi and let us use him to work in one of our national teams. Are you going to hear about Messi? No. Messi is Messi, Ronaldo is Ronaldo, because he is Ronaldo, yes, but because he works in a team. He cannot work alone. I met people, they can work alone, but they cannot work in a team. One day, a simulation team, crew, helpers and operators came to my office. They have a complaint from their manager, the supervisor in the field. What's the complaint? They said, Ahmed, we have two main issues. First thing, that when we go to the field, he always tries to find himself a good place to stay in. And he doesn't care where we sleep. Second thing, when we start a job, and if during the job we have a problem, he always tries to solve the problem himself. If he failed, he always called you, Ahmed, to solve the problem for him. He never asked us to join him, to get our feedback if we can help him solving the problem or not. And honestly speaking, Ahmed, sometimes we know the problem and we know the solution, but we shut our mouth because he believes that we are just chairs sitting with him. Listen to their complaint. I called the supervisor. He came to my office. I explained to him the problem, the complaint he got from his colleagues. He said, Ahmed, give me 2 days. And yes, after 2 days, he called me and said, Ahmed, problem is solved. I said, how come? Come to my office. He came to my office. He said, Simply, I listened to the complaint, I thought about it, I found myself guilty, and I apologized to my crew. This is the attitude we are talking about. This is the man that we need. From that day, this man is on top of my head. He admitted he made a mistake. He apologized to his crew. Now he can work in a team. He is not working alone. Democratic approach. We need people that they share ideas with their crew. Dictatorism exists and it has to be there. Democracy is not an open world. You cannot make a meeting in the morning before we go to the job, and or at home when I'm home and I have a meeting with my wife and my kids, and let us discuss, should we drink marijuana at home or not? If the majority, I mean by the majority my wife and my kids decided yes, we need to smoke marijuana, then this is democracy. I have to obey the majority. It doesn't exist. I have to be a dictator in this. No marijuana in my home. Same in the oil field. We cannot discuss in the morning, guys, should we go to the field wearing helmet or wearing caps, jeans caps? We cannot discuss this. This is not democracy. When we talk about safety, you have to be a dictator. This is the PPE, the personal protective equipment we use for this particular job. If you don't like it, go home. Full stop. But in operation, no, it is not the word we use. You have to be a democratic in your decision. So before we go to the job, we do what we call toolbox talk. The toolbox talk, it's safety meeting. We do it just before the job. Who attended? Everybody attended. Everybody, even the crane operator, the truck driver, they attend this meeting. Where we do it? On location, on top of the Christmas tree we are going to deal with. Why we do it on the Christmas tree? Because normally when we do a job, who designed the job is the operating company. But when the service company is going to do the job, the philosophy of doing the job from the point of view of the operation team, which is the owner of the wellhead, might be different. As a service company, when I go to the Christmas tree to make my safety meeting, and I found that the Christmas tree, around the Christmas tree, we have a bit, we call it a cellar. It's a hole deep, 3 meters, 4 meters. This cellar has to be surrounded by gratings, avoid people falling down during the job. If there is no grating, then I will see it by my eyes that, oh, I cannot do the job. Grating should be erected before we start. That's why the safety meeting has to be on location on the Christmas tree itself. Everyone attended, we do it before the job. What we discuss in this safety meeting? We discuss a lot of issues. Number one, we discuss safety. Gentlemen, this is the job. We have a one sock here. We have the fire extinguishers surrounding. If we have to escape during emergency, we have to follow these routes. This is the assembly point. We have to discuss what we call risk assessment. During the job, if this problem happened, this will be the solution. If this happened, this will be the solution. This is what we call risk assessment, to try to see what could happen, and if it happens, how we protect ourselves. We discuss operations in a very simple way, because the program, how to do the job, might come from the operating team in English word, but some of my team doesn't know English. Some of them, they know English, but they didn't read. So you have to discuss the operation in a very simple way and to be sure that everyone understands exactly what he's doing. In this safety meeting, we have to discuss responsibilities. Who's doing what? Who's going to sing? Who's going to dance? Because if we all dance, who will sing? Who will play the drum? So we have to discuss who will run the cold tubing unit, who will run the wireline unit, who will deal with the Christmas tree, who will deal with the crane operator to give him signal, who will deal with the company man to get the orders from him or to discuss issues with them. So we have to clearly mention this in the toolbox talk or in the pre-job safety meeting. We have to discuss this as well. Then it comes the most important point. If we finish all this, as the man in charge, you cannot say, okay, guys, let's go for the job. You have to see their feedback on what you said. And look at the word we are using, encourage feedback. Not listen to the feedback, because listen to the feedback, okay guys, any question? No, okay, let's go for the job. But no, encourage feedback. Encourage feedback means after you ask this question, you have to go by your eyes through them. And if you see someone who needs to say something, but he's shy to say it, because he's ashamed to say it, or afraid to say it, encourage him to say it. And please, during the meeting, if the supervisor said something that you don't understand, don't wait till the end of discussion and then ask him. Or say, okay, I'll write it down and at the end I will ask him. No, stop him immediately and ask him. Sorry, I was sleeping. Would you please repeat what you said? This is how it goes. And this is what we call democratic approach, because if your helper mentions something which is better than you said as operation-wise, you have to change your program as per his suggestion. This is what we call democratic. You listen to the other, and if the other said something better, you change the program. Yes, you change it. Communications and coordination. We need people that they can communicate to each other. If the only language I speak is Arabic and your language is Romanian, we cannot deal with each other. We will not understand each other. So we have to have a sort of communication. Language is one of them. Devices is one of them. Some jobs, it's very critical that a team, these 3 people or 4 people, they have to have a communication around the clock. So they use walkie-talkie, for example. So communication is very, very important. Responsibilities. We need people that they can have responsibility. I met people during these years that they hate responsibility. I create companies, service companies. I work as a consultant to create this oil field around the Middle East. Yeah. So one day I was working as a consultant for some investors in Egypt to create an Egyptian simulation company. So we were looking for a GM, general manager. So I traveled to Abu Dhabi, met with someone, and I never met him before, but I came to know that he is good. And all the feedback is that he is a good man. So I asked him that, okay, I need you to join us as a GM, general manager. He said, Ahmed, no, thanks. I can join you as an operation manager. That's his field. When you guys grows up in your career, at the beginning, it is your experience, you gain it. But by time, your decision-making level comes better than your experience. When you reach this GM, it is a decision-making chair, not an oil field chair. I like that. I like people who knows their capabilities and where is the best for them. I met people that they don't like responsibilities, but in oil field, we need people that they can take responsibility. When you give him a job, he can handle it and he can take care of it. I know people that he is responsible for the job. When one of his team makes the mistakes, he said, it is my fault, not the operator's mistake, because he is in charge of the job. He should take responsibilities. That's why we see ministers resign because of a mistake of a labor in his ministry. This is about human. I hate taking to the wall again. We are not, I'm not fighting with you guys. We said human number one, equipment number two. What about equipment? People who work with the equipment, they should have full inventory here before it is in book. Yani, we cannot ask, I am a company man and we are doing a critical job. Then I go to the wireline supervisor. I said, well, we are looking for, we're going to run a gauge cutter in the field 2.3. If his answer is, okay, Ahmed, let me check my toolbox if I have it or not, you know what I should do? I should make a hole and bury him in the soil. Because he should know exactly what he has. Because the well intervention science, if I need this tool, I need it now. Now means now. Independent inspection. Every equipment we send to the field has to be inspected before we send it. It has to be a valid certification that a third party came and inspected. We make an inspection for the, we make pressure test inspection, we make wall thickness inspection, we make an inspection for the whole safety gears. We have, I'm talking about firefighting system like fire extinguishers, blankets, escape sets, oxygen masks, breathing apparatus, safety belts, safety harnesses. It should be inspected. And by the way, it's not just this we do to keep him fine. I always say, let me give you a life example of that. One day I was working in Abu Dhabi at the beginning of my life. And it was a rigless operation. Rigless operation means there is no rig on location. So the service company will come to the desert and they rig up their equipment directly on the Christmas tree. So the service company came, they put the equipment on ground, and before they rig up on the Christmas tree, the company man, the company representative has to come to check the equipment before he gives the signals to them to start the job. So the company man came, make a tour, look at the equipment, and at the end, after his tour, went to the supervisor. He said, thank you very much. Please take your people, your equipment, and go home. And the supervisor was shocked. What mistake he did. He didn't even start the job. So he left. And the answer came in the company man report. He said that during inspection of equipment, he found that none of the fire extinguishers are in working condition, although all of them are certified. All the fire extinguishers were certified. They have the tags on the fire extinguisher itself that it is still valid, the certification is still valid. But none of them in working condition. One of them is empty, one of them has a broken gauge, one of them has no handle, one has no hose. So what's the use of the fire extinguisher if it's empty? So that's why always visual inspection is very important. Time is running. So machine suitability. We have to be sure that the equipment we are sending matches the job we are going for. We cannot, as a company man, ask for a pumping unit that you need to make tests for the Christmas tree to 5,000 PSI. And I send you pumping unit rated for 3,000 PSI. It will not do the job. We need to run the coil tubing unit, the pipe inside the well, to 15,000 feet. And I send you a coil tubing unit only 13,000 feet. It will not do the job. So we have to be sure that it fits the job. We have to make pressure tests. We have to have spares and backups. We have to have a preventive maintenance. If I'm a company man and you are a service company and you bring me your equipment and before I allow you to enter my site, I say, bring me your file. And if I look at the file of your equipment and I find that the last maintenance you did was 6 months ago, you know what I will do? Take your book, you see this door, go out and close the door. I don't want to see you again. So plans and procedures, we have to have plans, how to do the job and what's the backup if this doesn't, we decided to run in the whole coil tubing to 10,000 PSI, to 10,000 feet, and then start mixing acid, run in the hole and pump acid. What if we run in the hole, but at 5,000 we're stuck? What about the acid we mixed already? How are we going to deal with it? So you have to have a backup plan. Let's talk about barrier. And let me ask you a question. Do you know what's barrier? And then people start telling me what's barrier? Whatever in Arabic says that haggis in Arabic. I said, well, I can go to the dictionary and discover this. What does this mean? What's the meaning of the word? Actually, if we ask ourselves what kind of well service disaster could happen caused by pressure, and this pressure, P-R-E-S-S-U-R-E, this is the word that we are all here for. If there is no pressure, we have no problem in the oil field. If any problem in the oil field, if you look at the root of the problem, you will find pressure somehow. Pressure will cause what we call blowout. What causes blowout? The barrier you select is failed to do his job. What is the barrier? The definition of a barrier? It is any device, fluid or substance, that prevents the flow of hydrocarbon. Like Christmas tree. If the Christmas tree is closed, this will prevent. Like blowout preventer, BOBs, stuffing boxes, strip rubber and coil tubing and wireline. Wireline plug, the plugs that we are running in the hole to set it in the tubing to prevent. Some people say downhole safety valve. The downhole safety valve is a device that we run and set in the production tubing that when we close it, it will prevent. So according to this definition in front of your eyes, any device, substance that prevent the well flows, then it is a barrier. But we, in the well intervention, we don't consider it a barrier. We consider it an emergency barrier. What's the difference between a barrier and an emergency barrier? It's like this example I'm giving you. This is my wallet. If I have 200 pounds in my wallet, which I put it in my jacket now, and then I have 300 pounds in my pocket. let us talk about dollars because you might know, doesn't know what pound is. So I have $200 in my wallet and I have $300 in my pocket. If you ask me how many dollars I have 300. Come on, Ahmed, you have another 200 in your wallet. I said, no, I don't see them. I live my life with the $300 in my pocket. This $200 in my wallet, I will show it to you when. When you put the knife on my neck, I will give you my wallet, my trouser, my shoes, everything. Emergency. So a downhole city valve, we call it emergency device. So if the well intervention say, if the API standards say that the minimum number of barriers you have to have in any types of job 2, when you count these 2, don't consider it downhole city valve because this is extra. This is extra. It is not a barrier, but emergency barrier. We classify a barrier into 3 categories: primary barrier, secondary barrier, tertiary barrier. So normally, when we run in the hole using whatever device, using wireline or coiled tubing, we always use our primary barrier, which normally it's a rubber item that seal around whatever this is called tubing or wireline. So we are running in the hole now, and this rubber element that seal around this wire or this coil or this pipe prevent a well fluid or a well pressure coming out. This is normally our primary barrier. If during the job this primary barrier failed, what we have to do, first thing is to stop operation and use our secondary barrier. Why we have to stop operation? Because the only barrier that can work while running in the hole or pulling out of the hole is the primary barrier. Any other barrier you are going to use, it is designed to work in a static condition. That's why you have to stop operation first and then apply secondary barrier. Normally, secondary barrier also is a rubber device, which is the BOB, blowout preventer, that when we close it like that, it seals around this wire or this pipe. If you apply your secondary barrier, and this secondary barrier you apply failed to prevent the pressure coming out of the well, that means your primary barrier failed, your secondary barrier failed, then you have to use your tertiary barrier. Normally, your tertiary barrier is a shearing barrier, a barrier that shears. It cuts to be able to seal. In if you take slick line or wire line, normally our primary barrier is the stuffing box, which is the rubber iron that seal. Secondary barrier is the BOB, which is again a rubber iron that seal. The tertiary barrier is normally what we call, either it is the Christmas tree, that it has a shearing capability in the swab valve, or we have a shear, what we call a shear seal, safety head, shear seal BOB. It's a BOB that shear and seal at the same time. In Christmas tree, if we are using a slick line, will be our tertiary barrier, because one of the valves of the Christmas tree has the capability of cutting the slick line, which is the upper master valve. The Christmas tree normally it has swab valve, upper master valve, and then the lower master valve. In upper master valve, we say sub-upper master valve can cut the wire, can cut the slick line. It has the ability to cut. What about the swab and lower master, Ahmed? I said, if you close them on a slick line, it will cut, but it will be destroyed. You are going to damage the valve because the swab valve and the lower master valve are not designed to cut. It's like exactly a ladder. We use a ladder. I use a ladder. The design, the philosophy of a ladder is to put it on the wall so I can climb up and turn the bulb at the top, at the ceiling. But you can tell me, Ahmed, I can use the ladder I use it as a bridge between two discs. And I put the ladder like that, and I can walk on top and go to the other disc. Yes, you can do that. But one time, while doing that, the ladder will fall down. Because the ladder, when we design it, we didn't put in the stress analysis we are making. He will be subject to this kind of force. It's like valves. All valves you are dealing with. Butterfly valves, ball valves, are designed to work either fully open or fully closed. You cannot use them partially. You cannot bring what we call butterfly valve, and you have a big tank full of water, and then at the bottom of the tank we have a 3-inch butterfly valve. Then you open it partially because you want to wash your hand, and then close it again. By doing this, you are destroying the valve. You will not notice that from the first time. But do this few times. One time, when you close the valve, it will not hold the pressure behind it. It will leak. Because all these times you were opening it partially, the water while going out, it erodes the sealing surface of the valve. That's why butterfly valve, ball valve, needle valve, either fully open or fully closed. The only valve that work partially, as far as I know, is the valve we put on the Christmas tree. We call it choke. The choke on the Christmas tree, it is designed to work partially. But then, so keep this in your mind. So normally, Christmas tree valves, swap valve, upper valve, lower muzzle valve, all of them will cut in wire. But the swab will be damaged because it is not designed to cut. So if you go to the supermarket, if you go to Carrefour or Spanish or whatever, GC Pennies, you go to the shelf of valves, you see 2 gate valves, same color, same size, same manufacturer, same pressure rating. One worth $1,000, the other one is 1,500 US dollar. Then you ask the salesman, there is a mistake in pricing. You say, no. This expensive one can cut the wire. So it's an added value. Normally, when you close the swap valve on the Christmas tree, it's a gate valve. So it goes closed until it goes to its bed to make the seal. What makes the seal is this edge. If there is a wire, there's a thick line, it will cut it. But it will be damaged because it's not designed. So if you need this gate to cut the valve, to cut the wire without being damaged, I said, would you please pass after 1 hour? Then I take this edge to make some heat treatment. So when it cuts, it will not be damaged. This heat treatment I made, it costs extra money. That's why this valve is more expensive. So some upper master valve can cut the slick line, not all of them, if they are not designed for. This is a nice example. What can happen when you unset a retrievable bridge plug and don't have enough weight above it? The retrievable bridge plug, it's a plug that we run it with a slick line or wire line, and we run it through the production tubing. Then it passes the production tubing to go to the open hole, to the casing. And it has a rubber element that inflates to sit against the casing, not against the tubing, to do a certain job. Once we finish the job, we run back to retrieve it. Before you retrieve this bridge block, what's the first thing you should do? I don't hear you, unfortunately. You have to equalize the pressure. Because this is the valve. What's below the valve here is pressure. Above it, there is no pressure. This differential pressure, if you try to retrieve this, the moment you retrieve it, it comes out of its place. This pressure will push this valve to the sky. This will be the picture you see. This is what we call a blowout. Do you see this tubing on the ground? This is 3.5-inch tubing. What pushes it all the way? Pressure. You see this disaster? This is one of the questions you might have in the quiz. What is the coincidence of the blowout? What blowouts makes? If we put it in categories, I said the impact of the blowout, number one, life loss, people will die. Number two, what you see, environmental loss. Number three, financial loss. You destroyed the field, the reservoir. Number four, reputation. Your reputation will be affected, definitely. Number five, we said extra governmental regulation. It's exactly like in the old days, when I travel, I go to the airport, maybe 2 hours before the flight departure. Then we pass by 1 or 2 checkpoints quickly, and nowadays it's completely different. They check me out. I have to go 4 hours before the flight departure, and they start checking me out before I even enter the airport. I believe the next step, before you go out of your home, you will find a checkpoint. Then you take your clothes off, they check you, then you go out, you wear your clothes, you walk 2 steps, would you please take your clothes off? Well, I just did here. Oh, would you please do it again? This bottle of water, I cannot take it with me to the airplane now. It's extra governmental regulation that makes our life much harder, but because of these incidents that happens. And this is the tubing that came out of the well, and this is the bridge block. This is the retrieval bridge block. They found it. Where they found it, this is the rig site over there. And if you have a measuring tape to measure the distance between the rig site and this bridge block, it's 400 meters, almost half kilometer. This was not there. This was 1,000 feet below the earth, below the ground. This is what pressure makes. So you have to equalize. That's why to open a valve, you have to equalize the pressure. We have special types of valve that can open and close under pressure, but the majority of valve, you have to equalize the pressure. What the API said? The API recommendation said that a minimum of 2 tested and the available barrier, regardless of the type of operation. So at any particular job you are doing, the minimum number of barriers you have to do is 2. When we deal with well intervention, as I said, well intervention for us means either coil tubing, wireline, or snubbing. Because these 3 service we do it under pressure, we work under pressure. The minimum number of tested and available barrier are 2. That's why we always use 3, because during the job, if one failed, we're still covered by the API. We have 2 till we fix the 3rd. Or we pull out of the hole to rearrange our barriers. So the minimum number, keep in mind, regardless, drilling, workover, well intervention, 2 is the minimum number, regardless of pressure, even the pressure is 0. In drilling, the 2 barriers we are using are the BOB and the fluid, which is the mud. The mud is always our primary barrier because this is the first thing that will face the pressure downhole. If it fails, then our secondary barrier will work, which is the BOB, blowout preventer. In well intervention, it is the opposite. We start the barrier from top down. So our primary barrier is the rubber element, that C, which is the stripper. Our secondary barrier will be the BOB, the blowout preventer. Our tertiary barrier will be the shear seal BOB. If this shear seal B is not, then it will be our Christmas tree. two types of barriers we have. We have mechanical barrier and we have hydrostatic barrier. In mechanical barrier, we have two types of it, closed type and closable type. What's the difference between the two? A closed type is closed throughout the operation. As we discussed, we're running in the hole, we have a rubber element, whatever is stripper or stuffing box or slick line, and this is our slick line or our cold tubing. During running the hole, this rubber element, it's always closed on this metal while running in the hole or pulling out of the hole. That's why this is closed type. But the closable type is like BOB. It's closed when required. That means it's open by default. We close it when it is essential to close, like a blowout preventer. The blowout preventer, while running in the hole or pulling out of the hole, it's always in open position. When you close it, if your primary barrier failed, then you have to stop the operation and close your secondary barrier, which is the BOB. That's why it is closable barrier, not closed. The other type is the hydrostatic barrier, which is fluid. The word I just said is wrong. I should not say fluid. I should say liquid. Why? Because fluid is the holding company, where underneath it comes gas, liquid. Gas cannot be used as a barrier because it has no weight. So it has to be a liquid because the liquid creates weight. So a hydrostatic barrier, it's a liquid that creates hydrostatic pressure, a column that creates hydrostatic pressure greater than the formation pressure. If I put full stop, my word is wrong. Because if the formation pressure is 3,000 psi, I will create a column of fluid that creates 6,000 psi on top of the formation. This is totally wrong because this will break the formation. The formation will not withstand this excess pressure. So it's a liquid that creates hydrostatic pressure greater than the formation within 200 to 300 psi, within a certain margin. And it has to be monitored all time. If the fluid cannot be, if the liquid is not monitored, it cannot, the moment you lost monitoring the liquid is not a barrier anymore. These are three new categories: temporary barrier, permanent barrier, active barrier. What is the temporary barrier? From its meaning, from its word, it's a barrier that we use it temporary. It's like the blowout preventer. The blowout preventer we put on the top of the Christmas tree, we use it for this job. When we finish, we take it, put it on another job, we take it, put it on another Christmas tree, then we take it, we travel to South Africa to do the job there, then we take it to our yard. So each place we put in there, it is temporary. That's why it's temporary. A permanent barrier, a barrier which you cannot take it out, like the casing. If we case the well, when you run the casing and then you cement it, then this is a permanent barrier before you perforate it. Because you cannot take this casing out again. An active barrier is the barrier that works now. So if you run a slick line, you have your primary barrier is stuffing box, your secondary barrier is BOB, your tertiary barrier is the Christmas tree. If you are running in the hole, this is a nice question. If you are running in the hole and your primary barrier is leaking, how many active barriers you have now? And the answers you have to select from 0, 1, 2, or 3. Again, this is the slick line, you are running in the hole. It goes through your primary barrier, but this primary barrier is not holding the pressure, so pressure is coming out. At this snapshot, how many active barrier you have? 0 active barrier, 1, 2, 3. Zero. Come on, Ahmed. What about we have BOB, we have Christmas tree? Yes, you have it, but they are sitting as Starbucks cafe. waiting you to activate them. But before that, the only active barrier you have, you lost it. Then at this particular time, you have zero active barrier. Zero. This is what active barriers mean. Any barrier we use, you have to test it from its direction of flow. So if you are running a plug in the production tubing, this is the plug you run in, how you test it? Direction of flow. What's the direction of flow is this direction, then you have to test it from this direction, not from the top. You cannot have a BOB and open a blind ram in the BOB blowout preventer like that, and you test it from above. It was not designed for that. The BOB is designed to hold the pressure from this direction. So you have to test it from this direction. Actually, if you test it from this direction, you hurt the BOB. This will be recorded in his memory. You do this mistake once, twice, 3 times, then it will not hold pressure from here or even from there. So don't use it wrongly. You test the barrier from direction of flow. This table represents the 2 types of barriers we talk about. Mechanical barrier and hydrostatic barrier. We said in mechanical barrier we have either closed type or closable type. A closed type like stuffing box, grease injection head, this is a wire line, E-line, electric line, the stripper in the coil tubing, wire line plug. A closable type like BOB and Christmas tree, closed because they normally open and you can close them when it is required. In hydrostatic barrier, it is any liquid fluid like drilling fluid, completion fluid, fresh water, salt water, all these fluids you can use that to create hydrostatic head on top of the formation that creates hydrostatic head greater than information pressure. Greater than information pressure. So please, I put 2 boxes here empty. So drilling fluid, completion fluid, can I put underneath here diesel? Can I use a diesel as a barrier? I can hear some of you say yes, some of you say no. What's the answer? The answer is no. Why no? I have 2 issues with the diesel. Number 1, safety-wise, it is flammable. Number 2, it is light. It will not create enough hydrostatic head to overcome the hydrostatic formation pressure. This is generally, but and remember this course is we are talking general knowledge, but if you need to go in details, what I'm saying is not 100% correct. It's like exactly when I teach you like poison is a killer. There is no doubt about that. If this bottle is full of poison, and if I drink it, I will die. This is simple. Yeah. But in some application, if you are sick, you go buy a medicine. If you look at the ingredients of the medicine, you will find poison in one of the ingredients. So can we say poison is the medicine? No, generally poison is the killer. In some application, poison is the treatment, yes. So it is true. Generally speaking, diesel cannot be used as a barrier because of these 2 reasons, safety and lightweight. But in some application, diesel is the only barrier I can use. In synthetic formation, which is the only compatible fluid that can deal with this formation without affecting the formation is diesel. Compatibility. Number 2, if the formation pressure is very light, very low, I cannot use brine because it will destroy it, it will crack it. But generally speaking, diesel is not a barrier. The other box here, can I write nitrogen? Nitrogen is an inert gas. So safety-wise is perfect. Yes, but we use nitrogen in the opposite operation actually. We use nitrogen in lifting operation to lift the well pressure to the surface, because nitrogen has no weight. It has no weight. So none of the gases we can use as a barrier. What's overbalance? It's creating pressure greater than information pressure. The opposite is the underbalance, which is less pressure than information pressure. What's the inflow test? Remember, when we run a plug, put it in the production tubing to isolate the well. Now we need to set this plug. In which direction we should test it? We set the direction of flow. But now, if we put this plug at the end of the production tubing, how do you test it from direction of flow? You cannot. The only way to test it is to do what we call inflow test, where you bleed off the pressure above this plug and then close and bring this chair and weight the pressure gauge at the top. If the pressure gauge raised, that means this plug is leaking. This is what inflow test. It is bleeding off the pressure above the plug and monitor for buildup. Some people say, okay, Ahmed, we will bleed off the pressure above the plug. Should we bleed it to zero? I said, I cannot answer you this question. But I can give you the key so you can answer it yourself. If you put a plug, bleed off the pressure above it, you bleed it, but you have to avoid, while bleeding, you have to avoid creating differential pressure between the tubing and the annulus, between the pressure inside the tubing and the pressure outside the tubing, that creates collapse to your production tube. So you have to monitor what we call an annulus pressure, which is the pressure between the tubing and the casing. You should not allow this differential pressure to become greater than the collapse resistance of the tubing that will collapse. That's why it's not a must that it goes to zero. So an inflow test, bleed off the pressure from above and monitor the buildup. And then we have a question. What if, Ahmed, we put a plug and we cannot perform inflow test? Should we test the plug from above? You guys, because you just listened to me a while ago, I said we have to test the barrier from the direction of flow. This is the direction of flow. So testing it from above is against what I said. So you tell me, no. I said, your answer is wrong. Look at the words of the question. If we set a plug and we cannot perform an inflow test, should the barrier test it from above? Yes, it should. How come? Let's understand first. If you put a plug, why you cannot perform an inflow test? The only answer I can find actually that what if the wellhead is dead? The well is dead. So pressure here is zero. So bleeding off the pressure above, close and sit on this chair, you're going to sit on this chair 3 years. Nothing will happen because pressure below is zero. So you will not notice any raise in the wellhead pressure. So in this particular case, we put what we call positive plug. A normal plug will withstand pressure from this direction only. But a positive plug, it is a special plug that holds pressure from both directions, from below and from above. So if you cannot perform inflow test, please test the plug from above. What if, Ahmed, if it's not a positive plug, it's not a special plug? I said, take it out and put a positive plug, run a positive plug, run a plug that holds pressure from below and above, and then test it from above. But Ahmed, this is not the reason we put the plug. We put the plug to resist from this direction. How we should? I said we have a proverb in our language, in Arabic. it says that being half blind is better than being blind totally. So testing a valve is a must. So you are doing a kind of a test, and most probably if it holds pressure from above, it will hold from below. But you have to do a test. This is better than doing nothing. That's why a positive plug, it's a plug that holds pressure from both directions, above and below. We talk about the barrier, but this is a new expression, formation fracture pressure. What's the formation fracture pressure? Each pressure, each formation, like we said, this formation, its fracture pressure is 3,000 psi. Mean that it will hold, it will withstand pressure above it up to 3,000 psi. If you exceed, it will break. Break what? What's the formation? It's grains, right? These grains is apart from each other. And there is unseen links between these grains. There is a gap between each grain and other. That's why the oil will go through these gaps between these grains all the way to the surface. If you exceed the formation fracture pressure, you break it. Break it means that you break these unseen links. So these grains will get apart from each other, regardless, vertically or horizontally. But the moment you stop this pressure, stop pumping, the grains, when it comes back, it will not go to its original place. No, it will, it's gonna collapse. When it collapses, there is no gaps between these grains, so fluid cannot go through it. You damage information. That's why the formation fracture pressure, as an expression, it is the maximum pressure applied to the formation before it breaks down. Or we can use when it breaks down. Both are correct. Before it breaks down, because before and when, we are talking about 1/10 of psi. I will try not to talk too much, another 10 minutes or so. Formation damage. What damages formation? So many reasons can damage information. We can talk about 10, 15. But let's talk about the majority. If we talk about the majority, I will say two things are the norm. Pressure and fluid. Exceeding information fracture pressure. If the formation fracture pressure is 3,000 psi and you pump using 4,000 or 5,000 psi, you are damaging information. And please don't understand me wrong, because we have jobs, we call it frac job. Frac job means fracture job, that the formation pressure is 3,000 and we pump 10,000 psi. Intentionally, we know what we are doing. Yes, we are breaking formation, yes, and we are creating these gaps between grains. But before we stop, we fill these gaps with artificial grains that has high permeability. So if we stop pumping, these original grains cannot go back because we filled this space already. But this is another topic, not to talk about it now. Normally, if you exceed the formation fracture pressure, you damage information. The other, which comes number two, is the fluid. Fluid creates pressure, which we already talk about in number one. The other two elements in fluid is the compatibility and cleanliness. Compatibility, that the fluid we are using to treat this formation, it has to be compatible with the formation. Compatible means friendly to the formation. This is a steel jug. If I fill it with acid, acid will eat this steel, because acid and iron are not compatible. But I can fill acid into this, because this is plastic. Plastic and acid are compatible. They will not fight each other. That's why we do simulation job. to simulate the formation, we have to select the correct fluid. It is not if we drill a well and we start producing from this well, and the well is producing 1,000 barrels a day. And after a while, the production started to decline. It became 600, 400, 300. Then we said, okay, we decided to say, job. What we need to do is go down to the formation itself. We talk about grains, and we talk about this distance. This road that the fluid goes through, if you are true engineers, you will remember from your lectures in the university that we have a speed curve. So due to friction, the speed here it will be less because of the friction. So here on the walls of the grain will start accumulate scales, wax, paraffins. So this will narrow the distance or the road till it block it. That's why this is one of the reasons we stop or we have reduction in production. So we decided to run cold tubing and pump acid. This acid will go through these roads, eats these or dissolve these paraffins or wax or debris, and then we start full production again. Is it true that if we are doing an acid job, then we go to the store, drag HCl and use it? Of course not. Because HCl is not compatible with sandstone formation. It eats it, it destroyed it. Then if it's sandstone formation, then we have to go to what we call mud acid. The mud acid is a combination between HCl and high fluoric acid, HF acid, by a certain percentage. And not just that. Do we pump raw acid or diluted acid, or do we run acid alone, or we run additives? We have to add some papers, some salt, and of course we have to go to the people who knows. We go to the lab, we give him sample for information, we tell him we need to run acid, and this is limestone formation. Then he comes to tell you, okay, you're gonna run HCl, 15% concentration, and you're gonna add 1 kilo of anti-sludge and 200 grams of corrosion inhibitor and surfactant, and it's a science. And this has to be compatible. When they incubate one of the Gulf areas, one of the fields, they used to do a simulation treatment to this field for years. Till one day, they start to see a big declination of production in this field. Looking for the problem, why it happens, they discovered that the simulation treatment used, when it goes, it reacts with the formation. One of the end result of the reaction was pure iron. So this pure iron start accumulating till it blocked the formation. The only way to treat this, either to send the welder with a cutting torch through the production tubing all the way downhole to clear this, or to do a side track. That this problem happened from using a bad treatment. They didn't select a compatible fluid. The other thing is the cleanliness. The fluid we are pumping into the well, it has to be clean. That's why an injection well where we have wells around the oil field, we start pumping water to push this oil to come out because we lost gas. In this injection well where we inject water, we have to have a filtration unit. Because this water goes, it has to be clean. Otherwise, if it has debris or scales, it will block these roads in the formation to block it. So remember, pressure and fluid, these are the most common causes of formation damage. Surge pressure and swap pressure is also good factors. Surge pressure, when you are running in the hole too fast and you don't have enough clearance between your tools and the IV of the tubing you are running through. You don't have enough gap. So you will not allow equalization that happens around the clock while you're running in the hole. So you are doing like injection. Swap pressure is the opposite, while you are pulling out the hole too fast and you don't have enough clearance between the OD and the IV. This also creates swap effect. If you are doing swabbing, by knowing what you are doing, this is correct, like frag jump. But if you are doing by mistake, you're going to destroy your well. And I said the word, while running in the hole too fast, pulling with the hole too fast. This word, fast, is totally wrong in oil field. And that's why I always say the word slow, S-L-O-W, is disadvantage in our normal life. Ahmed is running slow. Ahmed understands very slow. Ahmed reaction is very slow. This is a disadvantage. But in oil field, slow is the correct word you select. When you run in the hole, run the hole slowly. When you pull out of the hole, pull out of the hole slowly. When you pressure test slowly and in stages. When you bleed off slowly and in stages. You cannot bleed off a line with 3,000 psi to open the valve immediately to bleed off from 3,000 to 0. One day I was in the field, witnessed a slick line job. They pull out of the hole, close the swap valve, which is top valve on the Christmas tree, and a gentleman is on the top of a Christmas tree having a valve, needle valve to open to bleed off the pressure above, which is the lubricator of the slick line, and the other one is holding a rope, a hose for bleed off. When I look at this picture, it's a disaster. First of all, if you start to open this valve, what comes out of the hose is the gas. If the wind direction opposite to you, you will die in no time, because H2S is the first thing that will come to your nose. And if you bleed off the pressure, 3,000 if you consider to have 3,000 psi, and we need to bleed off this 3,000 psi to 0 immediately. There is a relation between pressure and temperature, with each one drop of 1 bar, you will have a drop in temperature equal to ½ degree centigrade. So the 3,000 psi in the lubricator, which is almost 200 bar, if you need to drop it immediately, that will create a drop in temperature of 100 degrees centigrade immediately. So if the needle valve temperature is 40 degree, it will be minus 60. What's the problem with that? Well, if you have the information that iron become brittle at minus 40 Fahrenheit, brittle means it will be like the glass. If you have a treating iron, if you have a piece of iron, a piece of pipe, which is 15,000 psi pressure, if you decrease its temperature suddenly to minus 40, it will be like a glass. You say, it will break. Very dangerous. That's why slowly is the word you are using. And before I finish, I know that my time is over. I need to tell you that a question: what's the low pressure and what's high pressure? Yani, if I say 5,000 psi, from your point of view, this is high pressure or low pressure? What about 3,000 psi? What about 1,950? What about 1,400? What about 300? Where is it between low and high? I didn't see this line in API. I didn't see a line between low and high. There is no words in API low and high. The only time, as far as I read, an API that they mention low and high in this field, when we talk about pressure test. In the old days, when we pressure test our equipment to 5,000 psi, when we raise the pressure from 0 going up to 5,000 psi, passing by 300, 400, 500, we see our connections start to leak. Then the company said, Ahmed, you have a leak. I said,